In this video, I'm going to be talking about virtual methods. This is one of the trickier subjects in object-oriented programming. So there's going to be a bunch of slides and diagrams and code samples, but we'll get all through it. I'm going to talk about what's the difference between overriding and hiding. This is a commonly confused difference that we often run into when writing virtual methods, particularly in C#. And I'm going to talk about what's the difference between overriding and overloading. We're also going to talk about abstract methods and abstract classes. And then right at the very end, we're going to talk about a kind of a highfalutin concept called return type covariance. But C# doesn't even support it, so we're not going to talk about it too much. So let's go back to our example of last time where we had a person class and a change request and defect fix request and all of that. So I'll start up Visual Studio again, and down here in the main method, I'm going to once again create two person objects, Eric and Leah. And I'm going to see what happens if we try to write these things out to the console. And I'm going to do that in a bunch of different ways. I'm going to say, well, let's just write out this object. Let's write out the object if we call the toString method with the object as the receiver. And then I'm going to say, let's convert this reference to a person into a reference to an object. Remember, object is the universal base type, so we can make this assignment. And then I'm going to call toString on that object. And so you might think, well, obviously these three things are all going to do the same thing. Let's try it and find out. So I'm going to put a breakpoint here. We're just going to step in. All right. So first time, we're going to write out just as the reference. Next time, we're going to call toString. And then finally, we're going to call toString as we have converted the thing to object. And if we look at our console window, then we discover that it says person, person, person. And this is, well, at least it's consistent. But perhaps this is not very useful behavior. So the default behavior that we've seen for every other type that we've had, if we try to write out an integer or a nullable integer or anything else, decimals and doubles and dates and enumerated types, has always been to write out something useful. But for this type that we've just created, this class we've just created, person, it appears to be just saying, well, you're asking me to write out a person. So let's try to override that behavior. Let's see if we can get something slightly nicer. So I'm going to say, well, we want to convert this thing to a string. I'm going to create a method called toString. And it's going to print out the name instead of just printing out person. Now, you'll notice we got a green squiggly underline here. So as always, I always look at the green squiggly underlines because they're telling me that something looks bogus. And this says person toString hides inherited member object toString. So remember, you inherit the members of your base class. Object is the base class of person. Object has some members, including a method called toString. So person has inherited that. To make the current member override that implementation, add the override keyword. Otherwise, add the new keyword. All right, well, maybe it's not clear exactly what's going on here, but this is suggesting that what we need to do is add either override or new. So let's see what happens when we do one and then the other, and then both. So if I say public, let's go for new first. If I say public new string, toString, then, well, the warning has gone away. So the program must be right now. Let's see what happens. So once again, I'm going to step into the program. We will create our people and then write this out 3 times. So first time, just the variable. Second time, I'm going to call toString. Third time, I'm going to convert it to an object first and then call object.toString. And when we look at this, it says person, Eric, person. So when we did it as just the variable, it said person. It used the old behavior. When we called toString, it used the new behavior. And when we used the reference as object, then it used the old behavior. All right, so that's what new did. And maybe I don't quite understand why it did that, because now we're being inconsistent. Let's see what happens if we go back up here. What if we change this to override, as it suggested? All right, and we'll try that again. And this time, it wrote out Eric, Eric, Eric. All right, so now we are back in the land of consistency, at least. But it would be nice to understand what is the difference between the new keyword and the override keyword. And remember, the new keyword produced the new behavior only on this line, only on Eric.toString, produced the old behavior both times in the two other cases. Whereas if we used override, then we got the new behavior in all three cases. All right, well, let's go back to the slides. The toString method is a virtual method, and so I want to lay out for you how it is that virtual methods work. What you want to do is you want to imagine that every class has a bunch of slots, right? Just imagine there's slots that you can slide things into. The things that you slide into them are methods. Now, a derived class inherits all of the slots of its base class. It inherits all of those methods. For a non-virtual instance method, or for a static method, the contents of a given slot are always the same, right? So if I have a static method called foo, there's a slot for that method, and that method always contains that particular static method body. Here's the tricky bit. For a virtual method, the contents of a slot depend on the runtime type of the receiver, not on the compile time type, right? Because remember, the compile time type could be a base type, right? It could be object. But no, it depends on the runtime type of the receiver. So here's how it works. At compile time, the C# compiler figures out which slot am I going to call for this method call. Then at runtime, the method that is actually in that slot is called. So why are these things called virtual? Really, it's not a very descriptive term. I kind of wish that these kinds of methods had not been called virtual methods. If you take a look at how virtual methods are implemented in many programming languages, it becomes a little bit easier to understand why they're called virtual methods. But really, this is very non-descriptive for the user. I would have much preferred if they had been called overridable methods, because that's what they are. You can override them. So let me illustrate what I mean by slots. So here I've got objects. I've got classes drawn as the large outer boxes, and then the slots are the small red boxes in them. And then the slots in the more derived type have pointers that point to the method that is going to be in that slot. So object is a class. It has a slot for a virtual method called toString. Right? Now, if we had no method at all in person, as we did at the beginning of this video, we had no toString method at all, then person would contain a slot for the toString method because it inherits it from object. Right? Now, this is a virtual method, so the contents of that slot are determined at runtime. And since person does not have any toString method, the contents of that slot will be the method that is provided by the object class. Right? So we have taken some code in the object class and we have reused it in the person class. So remember, this is one of the goals of object-oriented programming, and inheritance in particular, is to say we're going to have some behavior in a base class. We wish to reuse that behavior in a derived class. So object's behavior is, as you can see here, the behavior of toString is it attempts to get the type of the current thing, and then it gets the name of that thing, and then it returns that thing as a string. And that's why we wrote out person, person, person. All right, so suppose we have a new method in person. We have a new toString. So now let's take a look at the situation. The object class is unchanged. It still has the slot that it has for its virtual method toString. It still has its default implementation of toString. Now, for person, we inherit the slot for the toString method from object. and we produce a new slot, right? That's why we put the keyword new on this thing. New means make me a new slot. So we now have two slots. One is the one inherited from object toString. The other is a new slot for person.toString. So at runtime, what are the contents of this slot going to be, of both these slots going to be on the person object? Well, object.toString says, well, I guess you want me to inherit from my base type the contents of the object toString slot. So its behavior is the same. But the person toString is a non-virtual method. It's an instance method. And so the contents of its slot are always the same. They're the thing that you provided originally. Right? So now we have two method bodies. The virtual method here that is used when person is used as an object. And we have the toString method on person that is used when person is used as a person. So let's briefly go back to the code real quick here and take a look at this again. So remember what happened when this was new. I'm going to turn this back to new here. All right. So the first time, we're saying console.writeLine Eric. Now, Eric is not a string. It's a person. So the console.writeLine method is going to say, oh, I need to turn this thing into a string. Well, what do I know about this thing? I know it's an object. And therefore, I will call object.toString on this thing. And we know that the contents of the object toString slot at runtime will be the original implementation, which is produce the name of the type. All right, so that's what it does. It produces the name of the type. There we go. Now, this code, the C# compiler will say, oh, you're calling toString on an object of type person. That's the receiver. You must want me to call the new method. You just said make a new slot on this thing that has a toString method. So that's the best match I can possibly make here. So I'm going to call that method. And sure enough, it does call that method, and it writes out my name. And then here, the C# compiler is going to say, oh, you're calling toString. The receiver I know is of type object. You must want me to call the virtual method. Well, what are the contents of the virtual slot? They are the contents as they were originally defined by object. And so there we have person, Eric, person. So now let's go back up here and mark this as override, like we did before. And now let's go back to the slides and think about how this works if we have an override method in person. So what's going to happen? Well, object is just the same as it always was. It has a virtual method slot called toString. When we say override, the C# compiler reasons, you must want me to change the contents of that slot at runtime rather than creating a new slot. So person inherits this slot from object. But at runtime, that slot contains a different method than this method that object provides. It contains a new method. So now, every time object.toString is called, at runtime, the person object will say, hold on a minute. I think you want to be calling this method, not the original method. And so once again, if we go back to the code here, then we can see that that's what happens. Right. We call console.writeLine on Eric. Console.writeLine says, that's not a string. You must want me to convert that thing to a string. I will call object.toString. And now the runtime says, oh, the contents of the object toString slot are this method. Right? And in fact, we could put a breakpoint here. Let's start this program over again. Right. And we see that when we hit this line, console.writeLine Eric, what happened? Well, we were in main. Then we called console.writeLine. Then we called sync text writer writeLine. And then we called text writer writeLine. And then this guy actually said, oh, I want to call the object toString method. And that dispatched to this guy here. Right? And so there we go. We're about to write this out. The same thing happens in the other two cases here. Right? In this case, we're going to say, oh, we're calling toString. What slot is associated with this thing? Well, you must want me. There's no toString method that was originally declared on person, that thing was an override. You must want me to call whatever is in the object toString slot, so I'll call that. And same thing here. All right, so I hope that makes sense. The key idea here is that the compiler is deciding which slot to issue this method call on at compile time, but the runtime is deciding what the contents of that slot are on the basis of what is the type of this receiver. That's the key fact about virtual methods that you need to understand. So I want to pause just briefly and summarize what I've just said in one place to make sure that it's all clear. So a new method creates a new slot, and that hides the slot in the base class. We call this method hiding, because when you call toString on a person object, and the object has a new method, then essentially what we have done is we've said, oh, we're going to choose the new slot over the old one. We're going to hide the old one from view. Overriding a method means at runtime, I want you to put this method into that slot. Now, I haven't said yet what I mean by overloading. I've used the word overloading a bunch of times throughout this course and the previous course. Remember, a method is overloaded if there are two methods that have the same name but with different signatures. So we saw with console.writeLine, for example. There's a version of console.writeLine that takes a string. There's a version that takes multiple strings. These are all overloads of that name. And I have been doing this for over 20 years, and I still sometimes say overloaded when I mean overridden, and overridden when I mean overloaded. I'm going to try really hard not to, particularly in this episode, but sometimes I may slip up. So now let's see what happens if we add a more derived type to the person class hierarchy. So let's go back to the code here. So what I've done here is I've made a type that is derived from the person type. So the person type has now become a base type. I'm going to say a president is a kind of person, but maybe it's a kind of person that has capabilities other than that of a normal person. I'll have a constructor here that takes a name that just passes that name along to the base type. And I'm not going to add any other properties or methods at this time. We'll maybe get to that later. So in the person class, I have made toString override the base type implementation of toString. Let's go back there real quick here and just verify that. So we have our class person, and I've made an override version of toString that just returns the name. And here I'm going to say, well, I'm going to override that even further and say that if you call toString on a person that is a president, then you should say, well, that is president name. All right. So now let's go back to our main method here. All right. We'll create a new president object, President Barack Obama. And then we will see what happens if we do a write line on Obama. So we'll step in here. All right, and sure enough, this says President Barack Obama. So that should make sense. We have said in the person object, I'm going to override the value of this. I'm going to override the method that is in the object toString slot. In the president object, we have said, I'm going to override that override. I'm going to provide an even different behavior. Right? And so even if we say here, you'll notice that I typed Obama as person. Right? We could here say Obama.toString. Right? And even though this thing is of type person, right, you'd think that if we stepped into this thing, that we would go to person.toString. Whoops. But no, in fact, we go directly to president.toString. All right. So that's overriding. How would we add our own virtual methods if you want to create a new virtual method? We've seen how to create methods. We've seen how to create static methods. We've seen how to create instance methods. To create a virtual method, you do it the same way as you create an instance method. You just add the keyword virtual to it. So here I'm going to say I have a public virtual method. It returns a string. I'm going to call it virtual method because I'm not good at naming things. And it's just going to return hello. One fun fact, if I say private here, then it says virtual or abstract members cannot be private. So this has to be something other than private. It can be public, it can be internal, it can be protected, but it can't be private. This is on the one hand, that kind of makes sense. The whole point of a virtual method is that you are going to override it in a derived class. You can't see the private members of your base class. They're private to the base class. And so how would you override it? Now, it turns out that there is kind of a sneaky way in which you can get around that we're not going to talk about in this course. But still, C# doesn't allow it because it says all virtual methods must be non-private. This has always been kind of a point of contention between me and the C# design team. I wish they would remove that restriction, but it's way, way low on the priority list, believe me. So it's probably never going to happen. But anyway, here we've created a new public virtual method in a base class. We've created it in the person class. And so now let's try to override that in the derived class. All right. So what if we want the method in the derived class to call the virtual method in the base class? The virtual method in the base class probably does something interesting. And we might want to say, you know what? I want to do that, and I want to do my own thing. So C# allows you to do that. There's a keyword. You can say base dot. So this now becomes the receiver of this call. And this means, please call this virtual method, but do not call the most derived version of that virtual method. Do a non-virtual dispatch on this thing. Actually call the base method. So let's take a look at an example of this. And so if I have President Obama here, right, then I can say, I would like to call this virtual method on this type. Remember, this thing is of type person at compile time, but it will be of type president at runtime. So let's step into this code here. I'm going to step over the toString, step into the virtual method. So even though the receiver was of compile time type person, the compiler has said, I am going to call the method that is in the slot for virtual method. And that is the method that is in the more derived type. But here, we are going to say, oh, you know what? I want to call the version of the virtual method that's in my base type. So if we step into that, then we step into the base type's virtual method. Does that all make sense? Let's take a look at this in a diagram just to make sure that we're all clear on this. All right. So I've made some modifications to our previous diagram here. So here we have the object, the ultimate base class. It has a slot called toString. And an implementation of the contents of that slot. Our person object also has a method toString. It overrides the behavior of the object type. So it says, at runtime, in this slot, put in this method. And our person guy says, I want to create a new virtual slot called virtual method. And at runtime, use this method here. Then our president object says, if I'm going to inherit the slot from my base type, right? So person has this slot, so president gets this slot too. But there's an override, and so it says, but at runtime, I would like the contents of this slot to be this method. And the same for the virtual method. Since it overrides a slot that it got from its base type, it says, I would like you to replace this method here with this method at runtime. Right? When this call here, base.virtual method, is resolved by the compiler does not say, I'm going to figure out which slot to call and call whatever in that slot. It says, I'm going to generate a call directly to this thing here. All right, so we've seen how to make a new virtual method. We've seen how to override an existing virtual method. You can also make virtual properties. So let's go to our base class here. I'm going to stop the debugger. We're back in the person class. and I'm going to add a new property. I'm going to say that a person can have a title. And I'm going to make this a read-only property. It just has a getter. It doesn't have a setter. And it doesn't even have a backing field. This property always returns an empty string. The title of an ordinary person is I have no title. And I'm going to mark this property as virtual. And then and it has to be public, because virtuals always have to be non-private. So it doesn't have to be public, but it cannot be private. All right, so then down here, I'm going to say I would like to override the behavior of this property getter like this. All right, so now, once again, if we go down here to our main method, and then I can say I've got a person, create a new person. I'm going to put a breakpoint there. All right, so now if we say what is Eric's title, right, then it says, well, it's an empty string. If we say what is Obama's title, then it says it is president. So even though both of these variables are of type person, the property has been dispatched according to what is the runtime type of this thing, right? The runtime type of this is President Barack Obama. The runtime type of this thing is Eric. So we've seen that you can make virtual methods. We've seen that you can make virtual properties. Most other things are not usually made virtual. You can't make virtual fields. We're going to talk about events a little bit later on. You don't typically make virtual events. Usually it's methods. Virtual properties aren't that usual. They're legal, as we've seen, but most people don't make virtual properties. So I want to switch gears a little bit here and talk about abstract types. We've seen we can make a person. We can make an instance of a person. We've seen we can make an instance of a president. That totally makes sense. We've seen in previous videos that we have these derived types defect, fix request, and feature request. That kind of makes sense. My question is, does it make sense to make a change request? Can we make an instance of that base type? But that is not one of the more derived types, right? We can make an instance of the person base type that is not its more derived type, president. That makes sense. But there are sometimes you have base types where you think, well, it doesn't really make sense to have one of those things, right? So for example, if we had a base type that was animal, and we had a derived type giraffe and a derived type tiger and a derived type elephant, then we could say, well, we'll make a giraffe, we'll make a tiger, we'll make an elephant. Can we make an animal? Right? Can we make something that is just an animal that is none of those derived things? And that kind of doesn't make sense. Right? Can we make a change request that is not a defect fix request, not a feature request? It's not any kind of request. It's just a change request. Well, maybe that doesn't make sense in the same way that making something that's an animal but no kind of animal makes sense. Or you can think of plenty of other examples, right? Like shape. You can imagine you have a shape base type and a square and a circle and an ellipse derived types. Can you make something that's a shape that's not one of these derived things? Probably not. So when you're in situations like that, what you do is you mark the class as abstract. So you can see I've changed change request here so that it's marked as abstract. An abstract class is just like a normal class, except that you cannot construct it directly. You can only get an instance of an abstract class by making an instance of a more derived class. So just to briefly make sure that that's all clear, an abstract class represents an abstract concept. It may not be instantiated directly. A non-abstract class is called a concrete class, although you don't usually hear that term very often. Almost all classes are concrete classes, so you don't usually need to call them out. And you can use the abstract keyword in the class declaration. All right, so going back to the code, that's abstract classes. An abstract class may contain an abstract method. It may contain multiple abstract methods. It is not required to contain an abstract method, but it may. An abstract method is a virtual method that can only occur in an abstract class, and it provides no body, right? So basically what we're saying here is we're saying, well, I would like change requests to have a virtual method called submit request, But I don't want to say how to submit a request. I don't know how to submit a request. I'm going to make it up to my more derived types to figure out how to submit a defect fix request or a feature request. So now that we have created an abstract type, an abstract base type that has an abstract method, we are required that all concrete types that derive from it provide an implementation for this method. They must override it. So let's take a look at our defect fix request here. You can see that we've now got an error. We've got a red squiggly reported here. It says defect fix request does not implement inherited abstract member submit request. And down here it actually also says show potential fixes, which is kind of nice. And we can actually go and say, Visual Studio, would you please implement this abstract class for us? Which is really a nice feature. So it's provided a new public override void method called submit request. And what does it do? It throws an exception. And this is Visual Studio's way of making sure that if you have code that calls this thing, that code will fail because you haven't provided an implementation for this thing yet. So it kind of goes one step along. It says, well, compilation is failing right now, but I can get the compilation to stop failing. But it's going to fail at runtime because you still have work to do. You never implemented this thing. All right, so let's just get rid of this here. All right, we would, of course, if we were actually writing code here, we would write code that submits this defect fix request to some defect database or something like that. But let's just put a breakpoint there. We'll do the same thing for feature request. All right, we'll say show fixes, implement abstract class. There we go. All right, and so now we have our implementations for our abstract method. So we can, if we have a change request here, right, of whatever, I'll just all right, now we can call submit request on this thing. And if we did, then we would step into the implementation that is in defect fix request. However, we are not allowed to say change request is equal to new change request. Right? Even though we have a constructor that we could use here, right? We could give it a title and a description and a person. Right? We would get an error saying cannot create an instance of an abstract class change request. You'll notice that the error says abstract class or interface. Once again, we have one of these error messages where the person who wrote the error message was too lazy to write two errors. We'll talk about interfaces more in a later episode. So we've seen how to make a class that is abstract that you cannot instantiate. We've seen how to take a virtual method and override it. Now here's kind of the opposite way to look at it, and that is to say, if you override a method, if you override a virtual method, essentially what you are doing is you are saying, the base type's behavior is not what I want to do something else. Which means that every time that the virtual method is invoked where the receiver is of the base type, then what's actually going to happen at runtime is determined by the more derived types code, not by the base types code. Now you might say, you know what? I have got this base type right, and I do not intend this base type to be, I do not intend this type to be derived from more. I don't want there to be a derived type that can potentially change my virtual methods. I don't want to change what toString means in this type ever again. Because I don't want to have to test all of those scenarios. I don't want to write my code to be robust in those scenarios, and so on. Right? Virtual methods come with a cost. And the cost is that when you call one of them, you don't necessarily know at compile time what's going to happen. You're kind of trusting that the code that you're calling is going to work. Now, Hopefully you wrote the code that you're calling, but maybe you didn't. Maybe this is code that's being provided by another team. Maybe it's being provided by a team that is going to be changing the behavior in the future, and so it's going to be difficult to test, and so on. So sometimes you might want to say, you know what? I'm not going to design this class for inheritance. I'm going to design this class so that it works the way I want it to work and that nobody is going to inherit from me. So if you are in that situation, then you can say sealed. Right? So for example, we might want to say, you know what? There's never going to be a type that is more derived than president. I'm going to seal this type. And now if we attempt to, now if I say class super president is a kind of president, right, then we'll get an error message saying super president cannot derive from sealed type president. I really like sealing my types because, as I've said several times in this course, I think that inheritance is often an overused mechanism. And I would like to say, you know what? I haven't tested this class for inheritance. I haven't designed this class for inheritance. I don't intend anybody to ever inherit from it. I'm going to seal the type. We'll talk about this a little bit more in the next episode. You can also seal a method. Right? So if down here we said, you know what, it's OK if somebody makes a derived type from president, but I don't want them to change the behavior of toString. Right? Then I can say that this is a public sealed override of toString, and now an attempt in a base class to override this toString method would similarly produce a compile time failure, saying you cannot override a sealed method. Now, you can always create a new method. Right? Somebody could create a new toString, but that wouldn't override the existing one, as we know. Summing up, sealed types. A sealed class cannot be derived from. A sealed virtual method cannot be overridden. And we'll discuss all of this more over the course of the next two videos. So finally, one more thing. I said when we started here that I was going to talk very briefly about a highfalutin feature called return type covariance. I want to give you a quick example of what that is. So let's look in Visual Studio here. Suppose I have a base class, which I'll just call covariance example base. And it has an abstract method. Could be virtual, doesn't have to be abstract. I just made it abstract so that I didn't actually have to write a method body here. I've got a method called example, and it returns a change request. Now I would like to make a concrete class that derives from this base class. And so, of course, I have to provide an override for this thing. The question is, could I say that this override could return, instead of a change request, could I promise that it is going to return a feature request? Feature request is derived from change request, and so it seems reasonable that this would be allowed. The base class method says, I am something that will return you a change request. The derived class says, not only am I going to deliver you a change request, I'm going to be more specific than that. I'm going to tell you I'm going to deliver you a feature request. So the contract has been met. The base class demands that the derived class provide an implementation of a method that can return a change request. It does. But this is actually an error in C#. This kind of manipulation of the type system is called return type covariance. And it's supported in some languages. It's supported in C++, for example, but it's not supported in C#. So if we look at this thing, here it says, return type must be change request to match overridden member. So C# requires that when you are overriding a method, overriding a virtual method, whether it's abstract or virtual or whatever, the signatures must match exactly. Right? So this return type must be the same. The argument, the parameter types must be the same. The names must be the same, and so on. So this has to be change request. And now the error goes away. So that's return type covariance. Very frequently asked question, why doesn't this work? It's also a very frequently requested feature for the C# team. They have considered it many times over the years, never made it into the language. But if you like it, keep asking. Maybe someday they'll put it in. So summing up, the compiler determines which method slot to use when it sees a method call. The actual method that is going to be called at runtime is determined by the runtime looking at what the contents of that slot are. This can be confusing, but it is a very powerful technique. Method hiding is usually unintentional. If you don't say new or override, then the compiler automatically picks new, which seems like it's maybe the wrong thing to do, but it's the safer thing to do, right? It's saying, oh, you know what? I'm not going to change the contents of this slot over here. You probably intended to make a new method. Let's just go with that. But that's why it gives you a warning saying you really should add new or override. I never said what happens if you say both new and override, and that's an error, right? You can't both say, I wish to create a new slot and I wish to override an existing slot. So once again, we see that C# gives you warnings for good reasons. Pay attention to them. If you have a type that you don't intend to be instantiated directly, then mark it as abstract. And consider ceiling types that you don't intend ever to be derived from.